Hello, guys, and welcome. Today I want to also teach about some organic chemistry, also to partially help me for my upcoming quarter as I'm continuing on organic chemistry. So I want to start with something I really struggled with, and that's stereochemistry and understanding whether something's an enantiomer, diastereomer, RNS configuration, meso compounds. So let's get started. So what we can tell here is this uh, molecules over here is stereoisomers, and I can tell that immediately because of wedges, dashes, and immediately looking at this. Wait, let me write down stereoisomer. Immediately looking at this, I can say that this is a diastereomer only because of the configuration between this and this molecule. But the thing is, we can actually furthermore test that with RNS configurations. So what we can do is look, we have three chiral centers, and then how we will be ranking it is by highest atomic priority. So this carbon to carbon would be 1, so we would have 1 here, 2 here, 3 here, and then we would have a dashed hydrogen here, which would be our 4th priority, but we generally ignore that. And and also pretend, moving on here, if since this is the CH3 over here, that would mean that the hydrogen would be wedge, which means that our R and S configuration would flip. So let's work on this part actually, because these actually don't relatively matter for the problem. So we have CH, C, C. So this would be our 1st priority, 2nd, and 3rd, and obviously the dashed hydrogen would be our 4th. So you would turn your clockwise. So we have R as clockwise, and then S as counter clockwise. So what we can tell is this is counterclockwise, so we have an S configuration over here. And then over here, we have, again, 1 priority, 2 priority, and then 3 priority. And then obviously our 4th priority, our hydrogen. Let me write that down so we can understand that. So generally we would be going S, but because, again, the hydrogen is on the wedge, we have to do the opposite, which would mean we would have an R configuration. Knowing this, that we're going to understand that this is a diastereomer. And same, different. Simple as that. All right, now moving on to the next problem. We have a little cube. I like to follow this rule, like count your carbons in, or draw them in, and then count your hydrogens. While it's not clinically relevant for each problem, I just kind of have a habit of doing it just so I can weed out any incorrections. Like, for example, if I looked here, I could immediately see that there's going to be no hydrogen bonding. Here would be 2, correct? But it's just to keep tabs on it, because those hydrogens, they get very they really sneaky with it. But yeah, okay, moving on. Again, dashed hydrogen, wedged hydrogen. Okay, so what we could tell is we have 2 chiral centers. I'm going to erase this so we don't get confused. So we have, let's see, CH3, and then we have our C. So I would say 1st priority, 2nd priority, and 3rd priority, which means we would go this way, which would mean this is clockwise, so this would be R. And then this part, we have our high priority over here, and then our 2nd high priority over here, 3rd over there, so boom. So this would give us a R, but, oh, see, flip because of the hydrogen, so this would be actually S configuration. Also, by the way, again, I forgot to mention, these are stereoisomers. Okay. Now going back to this one, we can also follow the same principle. Since these are practically the same, the molecule has not changed. This would also be S configuration. And then going back up, we would do the same exact thing we did over here, but I don't need to do the work again because this one's wedged, so this would be S configuration, which would mean this is a diastereomer. Okay, now we have this in mind. See, now this problem, you can't immediately, like, you can, but I would be very cautious about how you do this problem. I wouldn't immediately look at it and say this is a diastereomer. I would do R and S. So boom, two chiral centers, and then let's do it 1, 2, 3 clockwise. So R. Let me just erase this so that I can. It's better. 1, 2, 3, boom, R configuration. And then if we move over here, this is actually not R, actually, this is gonna be S. Because this is wedged, meaning that you have to have hydrogen dash, so this is actually S. Good thing I caught that. Okay, so we have 1 priority, 2 priority, 3 priority, boom. Counter, this is R because we do the opposite. Okay, moving on to the next. 1, 2 priority, 3, boom. Counter, so that would be R. Meaning that we have a stereoisomer diastereomer. Because stay the same, different. One thing different. So I didn't mention this before, but remember, enantiomers, R and S completely opposite. Diastereomers, R and S only has one opposite. Okay, let me erase this so it's not super clunky on the page. This part is a little tricky. This is something that I haven't properly learned. I just understand it because of process I learned in the book. So my thought process whenever I see these problems is okay, look here. I look at the alkene, because alkenes are double bonded. And I understand immediately because it doesn't have the same, it's not this way. This would be a cis, and this would be a trans, meaning that these are stereoisomers, diastereomers, because they're the opposite. But this, I'm gonna be honest with you, I can't explain it properly because I haven't even properly learned it. I just understand that concept that cis is trans is the molecule is same this way and this way, and that is some concept that I will learn the upcoming quarter. So because of that, I'm gonna completely skip this part. Okay, now we'll move on to this. So one stereogenic center, another stereogenic center. Okay, so I would number it beginning 1, 2, 3. We're going this way, so we're going clockwise, which is R configuration. 1, 2, 3. We're going this way, meaning we are S configuration, meaning we are stereoisomers that are actually, these are not diastereomers, these are enantiomers. These are completely opposite, so these are enantiomers. Our next problem, one stereogenic center in this molecule, another one here. We have 1, 2, 3, we're going this way, meaning we are 1, 2, 3. We're going this way. We do the opposite, so we're actually going clockwise. So this one actually would be R, meaning our molecule stereogenic is stereoisomers. Actually, these are not stereo. They're just purely identical. You wouldn't really classify as identical molecules. So meaning that this molecule is practically just flipped. Okay. And I'm gonna skip these because there's a trick to these, and I can't really explain it. I just know that when you're looking at the axial and equatorial positions, let me just draw them all out. It's not really clinically relevant, to be honest, but here, we'll just look at it. I just understand that when it's in the down position, or the equatorial position, it'll be trans, and then the axial position, when the equatorial and the axial when the molecules are in the equatorial and the axial position, you will get a trans. But when they're both in like equatorial, they're gonna be cis. And same applies if they were both in axial positions, it would be cis. The point is you want to have them in the same positions. So now the question is asking, for each compound below, identify all chirality asymmetric centers with an asterisk. I'll just be putting a star. We have one here. Okay, next we have one here and here. These would not be one because these are both methyl groups, meaning they're identical. You would have one over here. It wouldn't be here because you have a double bond. We're actually gonna have two over here, one here, and one here. Have one here, one here. We're gonna have two actually over here, one here, and one here. And the reason is because one methyl group, ethyl, this is kind of like a methyl combined here, and over here. Gonna have one stereogenic center here. Gonna have one over here, and over here. And the reason is because first of all, we have the alcohol group, boom, 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 different. It ends up becoming different further on. When you start here, you have different, it's completely, the molecule, if you split it in half, is completely different because it has a alcohol group versus here with a methyl group. Same principle applies here. And same principle applies here, a methyl group with the hydrogen. So that's why. And then OH, and then the bromine. Draw each enantiomer of the compound. Okay. CH3, fluorine, OH, dash hydrogen. We can test this out. Highest priority is, let me actually pull up the periodic table because yes, fluorine does have a higher atomic number, so it's actually going to be 1, 2, and then 3. And then we go this way. And this is S configuration. And then vice versa here. So we have our fluorine 1, 2, 3. So we go this way, which is our R configuration, aka meaning the enantiomer. Okay, and then moving on to the next one. Or OH. Our methyl, and this would be the opposite because test it out. 1, and then which way you want to go? You want to go to the left, and then the third, so you go this way, meaning that this is a S configuration, and then over here is going to be a 1, 2, 3, so you go this way, and that this is going to be a Excuse me, guys, I'm blanking out, but this is going to be an S. And if you test it over here, 1, 2, 3. Going this way, so you have an R. If you go this way, you have 1, 2, 3. So you're going this way. Again, another R, meaning enantiomers. And I'll have you guys do the problems here. And in about 5 seconds, I'll just be drawing in the answers and leaving the comments if you guys have any questions. Alright, let's draw them out. Let me know if you guys got this. Apologies. Fluorine. Bromine. Let me know. Is that what you guys got? Okay. And I will be stopping here. I think this is enough of the worksheet to get an idea of what we're doing. I will also be continuing and posting other forms of organic chemistry. Let me know how I can improve. Let me know if you guys have any questions. For reference, I am a human. I make a lot of mistakes. I'm using this also to learn gaps in my knowledge for myself. If I made a lot of mistakes, let me know. If my explanations were vague, again, please let me know. This is also a learning process for me. I'm just trying to teach what I know. All love, and I appreciate you guys for staying tuned. Thank you, and bye.